Hello, this is Mr. Simmons, and this is our ICP Section 1.1, the Methods of Science notes. This should be used in conjunction with the note outline here. This is worth 10 points and is due when I tell you in class. All right, as you take these notes, listen to me. I'll explain a little bit extra, expand on the notes, and then go ahead and copy down, fill in the blanks as you go. All right, so our vocab for this section is scientific method, hypothesis, experiment, variable, control, theory, and scientific law. If I go too fast, just go ahead and pause it and hit play when you're ready. All right, we're all scientists. Science is all around us. We all observe the world, ask questions, come up with answers, experiment, and conclude. A scientist is a person who observes the world around them. Observations are taken through your 5 senses: your sight, your touch, your taste, your hearing, and your smell. So what is science? Science comes from the Latin word scientia, which means knowledge. There are 3 main parts to science. The first one is life science. It studies living things, their parts and behaviors, and the relationship to the world. Earth science is the study of Earth and all that makes it up. It also looks at stars, planets, and moons and how they affect the Earth. Physical science is the study of matter and energy. Chemistry, our first semester class, is the study of matter. So we're looking at atoms, molecules, compounds, solids, liquids, and gases, reactions, solutions, and much more. Our second semester is physics. That's the study of energy. Energy is the ability to cause change and comes in 2 main forms: moving energy, which is kinetic, and potential energy, which is stored. A scientist observes the world, they question what they see, and they attempt to find answers. The scientific method. The scientific method is a way of thinking about problems and solving them. The first step is observe the world and ask a question. We're going to state the problem. The second step is to gather information on the problem. The third step is to form a hypothesis, an explanation of observation, an educated guess. Next, we'll test the hypothesis with an experiment. In an experiment, the factor being tested is the variable. In every experiment, there are 2 different types of variables. There are independent variables and dependent variables. The independent variable is the variable that the scientist is adding or changing in the experiment. The dependent variable is what happens. The independent variable is always put on the x-axis and is the cause. The dependent variable depends on the independent. It's the effect and is put on the y-axis. F-graph. When you do an experiment, there can only be 1 variable in an experiment. It's important to do this because we want to know what variable is causing the effects. If you're testing multiple variables, you are not sure which variable is causing the different effects, the dependent variable. So here we have an experiment. We have the same plant, A, B, C, D, 4 different kinds of the same plant. They're given the same amount of water every day, the same amount of sun, and what we're testing is the fertilizer type, A, B, C, and then none. This would be our independent variable. This is our dependent variable. The height of the plant depends on the different fertilizer types. So right here is our variable. An experiment ran or run without a variable is called a control. So in our previous experiment, what do you think our control was? It does not include the variable, so it would be D. D does not include the independent variables, so we can use for comparison. The next step is to gather data or results. There's two main types of data. Data with numbers is called quantitative data. It has the word quantity in it, and it means numbers. If we have data that involves descriptions, like tall, short, red, green, stinky, whatever, that would be qualitative data. It has the word quality in it. And it's a description or an adjective. So here our data is in the form of quantitative, so we have numbers. And at height after 2 weeks, we can see how the different fertilizers affected our plants. And we know it was only the fertilizer that caused these different effects because we had one variable, because the rest of these had this exact same amount, the same plant, same amount of water, same amount of sun, and we know the fertilizer actually positively affected the plant growth because our control group here, it grew the least out of the four. Next, we have to analyze results. Think critically. So which plant grew the most and why? We'll make a conclusion. Let's go back. So which plant grew the most and why? Well, if you look at the height after 2 weeks, it would be C. We know it's not the sun, water, or plant type. The only difference was the fertilizer type, and it grew the most. So our basic steps, there's a problem, we form a hypothesis, we set up a test, we gather data, we think critically, we evaluate the hypothesis, and we make a conclusion. If for some reason our hypothesis is incorrect, we'll go back to the beginning where we formed a hypothesis, we'll form a different hypothesis and perform the same test or a different test, depending on the situation. Scientific theories and laws. After studying facts, making observations, and performing experiments, scientists develop a theory. A theory is an explanation for events based on many observations and seems to be true. Theories that survive test after test become scientific law. So before we have the theory of evolution, it seems to be true based on an explanation for events and many observations. And then we can have the law of gravity, which is always true in almost every situation except for the quantum world. A scientific law is a statement that seems to always be true. Thank you very much. That concludes your notes. Have a great day.